What's up, everybody? Welcome to the Artists of Data Science podcast, the only self-development podcast for data scientists. Our guest today is a multiple award-winning technology and business leader whose career has spanned both public and private sectors. He holds several degrees, including a PhD in information systems, and is currently the founder of advisory, investment, and education firm Human Future, as well as adjunct professor in the School of Management at the University of San Francisco. And he's also a regular content creator of online video courses for LinkedIn Learning. He's a global thought leader on a number of emerging trends, including urban innovation, smart cities, sustainability, blockchain technology, data governance, and the fourth industrial revolution, as well as digital transformation. Today, he's here to talk to us about blockchain. So please help me in welcoming our guest today, the best-selling author, professor, founder, writer, and advisor, Dr. Jonathan Reichental. Jonathan, thank you so much for taking time out of your schedule to come onto the show today. I appreciate having you here.
Thanks, Harpreet. That guy sounds really interesting. I'd like to meet him.
Yeah, hey, I thought the exact same thing when I was going through your catalog of courses on LinkedIn. I was like, man, this guy is super interesting. You got such a wide range of interest, and your courses on LinkedIn are amazing. And I was immediately hooked with the blockchain courses, and that was really was my introduction into really understanding the technology. So I'm super excited to have you here to discuss that further. But before we get into that, into some blockchain thoughts, let's just learn a little bit more about you. Talk to us a bit about where you grew up and what it was like there.
Yeah, no, thanks, Harpreet. It's great to be with you. I was born in Ireland, no less. Yeah, I bet you weren't expecting that. I was born in the big city of Dublin City in Ireland, and I had an amazing childhood there and youth. And in my 20s, I moved to the US. I got a green card, and I've been here now just over 25 years. And technology guy all the way. If technology has been my career, my fun has been music. I've been a musician, and that's maybe we'll keep that for another podcast for another day. But in Ireland, went to school to learn about engineering and technology. Then I worked with my brother. Actually, we had a tech company together. But then in the US, I worked for a big firm in technology. And I spent actually almost 15 years with, at the time it was known as PricewaterhouseCoopers. Today it's PwC. And my last job there was really cool. I became the director of technology innovation. That's like a hobby. That's you're getting paid for doing your hobby. And I was like, when that happened, I said to myself, this is what I want to do for the rest of my life. I want to do something that feels like a hobby and I can make a living from it. And then I went to work for O'Reilly Media over on the West Coast of the US, working in Tim O'Reilly's team, a pretty neat guy. And then I had this sort of, it kind of happened by accident, but it was one of those really good accidents in that I was invited to be the CIO for Citi. When I say it was an accident, what I mean really by that is it was a surprise, right? It came from, nowhere, the invitation. And I said, well, let's see maybe what I can do. I wasn't necessarily looking to work in government or do public service, but the opportunity to work for the city of Palo Alto, which is sometimes referred to as the birthplace of Silicon Valley, was too interesting not to try. And, as the city manager said after I took the position, he said, we took a bet on you and you took a bet on us. And, I spent 7 years there, and, I have a lot of good stories to tell. And I actually through that gained a love of cities, and that's what I do now. That's my own firm. I'm helping cities and really bringing technology to bear on, how can we reinvent how you deliver the urban experience. And I've been lucky enough to write the book on it, Smart Cities for Dummies, as you alluded to in your intro, and it's a bestseller. So that's just a little bit about me, my background.
That's so cool, man. You've had such an interesting and varied career, man. How did this love of technology kick off? How did you get interested in it?
It's it goes back to two things. One is my brother was the tech guy at home, brought a computer home. He's my older brother. I stood behind him as he was programming and playing games, and kind of saw what he was doing and tried to emulate the code that he wrote. And then when I wrote, some very basic software as a child, I mean, really probably in, starting maybe 8 or 9 years old, my father was very impressed, so that was another driver. It's like, oh, look, I can do stuff that gets my father's attention and he likes. And so that combination of both, my brother being a role model and my dad appreciating the work, all lent itself towards something that, drove me to want to learn more and do it more. And it stayed with me ever since. I think, when I was about, I never know the exact age, but it was definitely sort of somewhere between 11 and 13. And I was getting quite good at programming some basic stuff on a Commodore 64. And my brother's friend asked me if I'd write a game that he would buy from me, and sell it through his company. And I thought, oh, that's interesting. And I got like the equivalent of maybe $200, something like that. And I thought, wow, you can do this and get paid for it. So, I was hooked at that point. I think if I kind of think about my career since then and my interests, I have recognized and do recognize that technology now has a central role in all of our lives, more than perhaps I even thought it ever would have. Having grown up through the 70s, 80s, 90s, and now into the 21st century, and with the emergence of the internet, everything changed, of course, and it's changed the world, it's changed our lives, it's changed how we work. And so I've always appreciated the value technology has in the world, how it, on balance is a good thing. There's a lot of challenges, of course, we know about them, but on balance, it's transforming the world for a lot of humans in a positive way, whether it's opportunity or quality of life, economics, that type of thing. And as I followed it and immerse myself in the industry of technology, I've done quite well, and it's encouraged me, and my passion and my interest has just grown ever since. Today, it couldn't be any greater because every business is a technology business, and we live in this technological time, this fourth industrial revolution, where everything has a technology slant to it. And there's no end in sight. It's just getting. It's going to get. Our world is going to become more automated, and technology driven in the future than it has ever been.
So let's talk about a new technology. Well, new-ish, I guess. It's been around since 2008, I guess, which 13 years in, but new to me, and most likely new to a lot of my listeners as well. And this is blockchain technology. So talk to us about, what is a blockchain, and how is this different from what we're used to seeing in data structures?
Yeah. Well, I don't know. It's always interesting where to start the answer to this. I should say the kind of iteration or the generation of blockchain technology that we're talking about today really sees its birth through Bitcoin in 2008. The idea of distributed ledgers, or more broadly, the concept of blockchain, predates that. But today, when people say distributed ledger, or blockchain, we all know what we're talking about. We're talking about the offshoot of Bitcoin, of cryptocurrency. And so to kind of get there to why it's different, I'll just spend just a moment on its genesis, right? So there's a paper written in 2008, and it proposes a new digital currency that allows for payments between individuals from basically what's called peer-to-peer. No banking system, no brokers, no middle intermediaries. Just if I want to pay Harpreet, I can just pay you directly. And it's a very interesting, compelling, provocative idea. Now, it's been tried before, and it was tried before 2008, but it for a variety of reasons, it didn't work. One of the core challenges to digital money is this problem that's written about in paper called the double spend problem. And in a nutshell, double spend means when something is digital, it can be duplicated really easily. You know, you have a graphic file, a JPEG on your computer, and you just copy and paste, and you have a second version of it, right? Think about that in a money sense. If I have the equivalent of $10, and there's two people that I need to pay $10, if I can just copy the $10 twice, pay you, pay the other person, well, wouldn't that be great, right? could have unlimited money just by copying and pasting. Well, look, you don't need to be a data scientist or a computer scientist to realize, well, that won't work. It basically becomes meaningless. You have to be able to send money digitally, and if I send you the equivalent of $10 digitally, I no longer have it, and you have it, right? There has to be a mechanism to make that work. And this is the secret sauce, the sweet spot. And so what you have is this idea of a ledger, right? You know, a ledger is something that you record transactions. Ledgers are 7,000 years old, by the way. You know, we didn't invent ledgers in 2008. What we have is a distributed ledger. So we're talking about an electronic ledger, something to record transactions in that is on lots of computers. In fact, it's on all the computers of all the participants who want to exchange this digital currency. And this distributed ledger is a type of database. It records all the transactions. And that database, that core storage of those transactions is what we know as blockchain. So that's what we're talking about, right? The underlying database. But the database works in a very unique way. It actually works in several ways. Number one, and this will, you know, if you're a data person, this is the first thing that will blow your mind. You can never delete transactions, and you can never edit transactions. The only thing you can do with a blockchain database is add new transactions, right? And so it's probably out of the scope of this conversation. There's a reason for that. I mean, number one positive is you have an entire audit trail of every single transaction, and you can validate things that way. So in this distributed ledger, these databases, these blockchain databases that are on everybody's computer, when a transaction takes place, when I send you money, that has to be recorded, and there has to be a process, some unique magic that prohibits me from manipulating my total, so it's authentic, and that magic is coded into how blockchain works. We may get to it, so I'll sort of kind of wrap up here. One thing that's really key for the layperson to think about with this blockchain technology that makes it different is, in society and in technology, we rely very much on trusting other humans, right? So, when I go into a bank and I give cash to the banker, that person puts it into my account, and I trust that it's happening, and I trust the bank, right? Which is really just more people. When we do business, when we buy something, we expect to get it delivered. So there's this sort of human element. And of course, There are lots of criminals, people who are bad, and they don't fulfill the trust. And well, we have a legal system to deal with that. But generally, if you think of the millions and millions of transactions happening every day, it's because we trust humans. What blockchain says is, no, we don't trust humans. In fact, we don't want humans to be part of the trust mechanism. We, in fact, want to be trustless. We want it to be trustless. And not that we don't trust it, but we want it to work without trust. In fact, what we want is the software code to be the arbiter of trust. And that's the big difference, than every other database that's come before it.
Thank you so much. That's a lot of great information there. A lot to unpack. So first thing is, every time I hear about blockchain, like in the same sentence almost, they talk about cryptocurrency. So
yeah.
Are they the exact same thing, or can we use them in place of each other? How does this work?
No, I'm glad you asked, because this comes up a lot. To go back to sort of my explanation of blockchain was born out of Bitcoin. So what we're trying to do back in 2008 and then eventually in 2009 is create this digital currency that's called Bitcoin. And it succeeds. And it's riding on top. It's an application that's riding on top of other technology. The other technology is called blockchain. Now, what happens is turns out to be that Bitcoin is open source, and there are other cryptocurrencies that are created from it. There are other cryptocurrencies that are not based off of Bitcoin that happen. And the underlying technology is used, the blockchain, to power it. But there's a realization, hey, this underlying technology that's powering crypto could actually do other stuff. It could carry other types of transactions. Maybe transactions to do with real estate, for example, closing, all the paperwork on a new property when you buy one. And there can be transactions, for example, that happen during the supply chain when products flow from a source to a destination. And creative, smart people sort of started to figure out, hey, let's try to use this underlying technology for other things. So blockchain becomes like the underlying operating system. We'll just use that example here for a moment. And on top of it rides all these applications, all these different uses. One of the uses is cryptocurrency. But now we find there are hundreds, maybe thousands of other uses. So they're very different things. Now, the connection, of course, is that for the most part, currently we need blockchain to run Bitcoin and to run Ethereum and Litecoin and Dogecoin and all the new ones, right? But we also now use a variety of different types of blockchain systems to run a massive amount of different other applications.
Yeah, that's an interesting point, right? So for listeners, there's not just one blockchain. Like the most famous blockchain is the Bitcoin blockchain, but
right.
Blockchain itself is just a technology, and there's several different kind of instantiations of it, right? And you mentioned that blockchain is, we can kind of conceptualize it as if it was a database. So in blockchain, databases provide more data integrity compared to traditional databases because we can only ever write to them, right? We can't delete anything, we can't change anything, right?
Mm-hmm. That is one of the features, right? So, straight away that's a positive thing, that if you want to look at every single transaction that was ever in a blockchain database, you can, right? So it has this terrific mechanism for auditing. This characteristic of not deleting but just adding is what we call blockchain immutability. We call it immutability. The weakness in traditional databases, and there are many, although they run the world today, right? The traditional relational databases, run most of society. They have issues. For example, they have an administrator, one or more administrators, and that person is a human being, and they make mistakes, and they are sometimes criminal. They add people or take away rights. So you have a lot of issues related to that. So the other feature, of course, with a blockchain is that it doesn't rely on humans to do that. It relies on code and this sort of particular type of, we'll call it just kind of I call it magic, but it's really mathematics, right? It's mathematics. And that is so unique to blockchains that it elevates the integrity or the security of every transaction in a way that traditional databases struggle. Because you can get traditional databases to be very, very, very secure, but there are failure points and there are weaknesses. Despite our best efforts, because we're dealing with code in blockchain, you've got to try to overcome some very significant mathematical challenges that are just so hard they're a deterrent to fraud. Now, that being said, there has been some attacks on blockchain, so let's be really clear about that. But it's been infrequent, rare. I mean, and we've recovered well from it. Unlike, unfortunately, the cybersecurity events that we see in the world today that happen every day and they involve millions of people, in different organizations, your bank, your supermarket, that type of thing. And those continue to happen. So there's vulnerabilities in both, but a significant difference in the ability for each to protect the integrity of the data.
Yeah, well, we'll talk a little bit about the mathematics stuff in a bit here, because I know you data scientists listening want to get to that part, but like if we conceptualize like blockchain as if it was a database, like does there exist like BCQL, like blockchain query language or anything like that? Does that even make sense to think of it in that way?
I mean, you can use SQL against a blockchain system. One of the things that's neat about the architecture of the technology is that it's open. Everybody can look at it. And now most of the identifiers that associate a transaction with a person are just a series of letters and numbers. So you can't. It's not easy to trace back. That Jonathan has sent Harpreet $1,000 or 1,000 Bitcoin or something. But you can see all the transactions from the very, very beginning, and you can export it. You could there's any number of data analytics products that you could run against it, just like any data store, 100%. Now, you can't affect the data, you can't write to it, but you can obviously read, and if you export it, you can do anything with it.
Mm-hmm. So kind of thinking about that, like, I'm just curious what your thoughts on here, because I know you've done a course on data governance as well on LinkedIn Learning. You've got so many amazing courses on LinkedIn Learning. Guys, go check him out. I will link to his LinkedIn instructor page. But like, what are the implications of blockchain technology for like data governance, data management? Have you thought about that at all, or am I just like sounding crazy right now?
No. A great thought. One of the things I think that every, let's say, chief technology officer has to think about is what is the platform they're going to build a solution in. And I've been doing tech for over 30 years. And you've probably heard this. You typically don't, create a solution looking for a problem. What you're doing in most enterprises is you've got a problem and you're figuring out how am I going to solve it. And so you don't say, we got a data related solution that we need to build to solve a problem. Let's try blockchain for fun. That's not good. IT leadership. What you say is, what is the best tech? And most of the time, it's going to be an Oracle database or a SQL database, or one of the Microsoft or SAP solutions. I'm probably leaving. I don't want to leave anybody out. Other solutions, right? Traditional databases. But you might, as a CTO, or the CTO team might say, this problem is supply chain related. It involves a lot of disparate parties who we don't necessarily trust or have any mechanism of trust. Maybe we should try blockchain technology. There's an enterprise version of blockchain called Hyperledger, right? That could be the one. There's also Ethereum, which can be used for quite very sophisticated applications. And so these get integrated into your environment, and they collect and produce data, and 100% they fall underneath your data governance strategies as an organization. It doesn't matter that one data store is Oracle and one is Hyperledger. You know, it's just data. It's just data being handled in a different way. So I want to, we as data scientists, we very much need to be starting to think about bringing the blockchain ecosystem into our purview, underneath our umbrella of systems that manage data, whether as an intermediary, as a producer, as a handler. So I say, if you're in data science and you're kind of curious about blockchain, soon that curiosity is going to move to, hey, it's going to be part of my responsibility. So I certainly think you've got to grow your expertise, and as an organization, you don't want the blockchain-based systems to be an outlier. No, you want to have the same level of oversight and ownership and security and all the things you'd have in a data governance program in order to leverage the value of that system and keep it secure.
And when we think about kind of the intersection between data science and blockchain technology, what's that look like? Have you seen, I guess, from your experience, how have you seen machine learning, data science intersect with blockchain? Or if you haven't seen it intersect with blockchain yet, how do you see it intersecting in the future?
Well, I think what you're seeing a lot is blockchain systems are becoming a part of a system, part of an ecosystem. One of the industries where blockchain is thriving is in the financial services, in fintech, and in some places it's helping to optimize existing services. In other areas, it's creating new opportunities. I wouldn't think of a Hyperledger being a enterprise-based blockchain as a standalone system. It's going to interface with lots of other solutions. It's going to consume and produce data, and there's going to be opportunity for ML and AI to be applied, as appropriate to your workflow. And so it is important to recognize, whilst blockchain is sort of the hot thing right now, or continues to be pretty hot, as sort of the excitement begins to wane over time, it becomes another tool in your toolkit of solutions that you can use in your enterprise, or use when you're building your startup, or perhaps as a consumer you're getting involved in non-fungible tokens. Maybe you're selling digital art or photographs or something, or you're a collector of digital things. Questions it's absolutely appropriate. I think there is an inclination to think that this is its own standalone world, and it doesn't coexist with all the other aspects of contemporary technology. The right answer is it's another part of our enterprise, another part of our enterprise architecture.
Definitely. And I think it's our responsibility as adults in our careers to keep abreast of these new emerging technologies and learn about them and see how it could impact you, or how it could influence the work that you do. And I know that's something you've been doing throughout your entire career. If your catalog of LinkedIn learning courses that you teach is any indication, you're really heavily involved in tech, and I admire that. Going back to blockchain, you talked about enterprise solutions. We talked about Hyperledger. I think this might be a good time to talk about the difference between public, permissioned, and private blockchains. So an example of the public blockchain is Bitcoin, right? That's a public blockchain. Anybody can kind of download that and become part of that network. So what's permissioned and private all about?
Yeah. It's actually a fascinating topic, because the original Bitcoin use of blockchain, as you have pointed out in your question, for it to work, it has to be public. It has to allow anyone to participate. You can't have a digital monetary system if it's restrictive. I mean, you can, but I don't think it'd be very popular. For everyone in the world to use Bitcoin, the system has to be open and available for anybody to participate. You don't need to have any credentials. Basically, you don't need permission. And that's what we mean by permissionless, right? So when we say public and permissionless, we basically mean the system is entirely open to anybody, anywhere to participate. And that's really healthy. I mean, that's, well, it's a little bit like if you came to the US, you should be able to get dollars and spend dollars, right? And then when you start to have other applications that run on top of other blockchains, like let's say a gaming platform that runs on top of Ethereum being another blockchain, you want the system to be open to anyone who wants to participate in that gaming world. Now, all of that makes it wonderful, also makes it challenging for an enterprise. Now, think about an enterprise. It's really the opposite of everything I just said. It is about limited access to systems. It's about permissions. It's about credentials. It's about, I only want certain people to see data or interact with my system. But I want the features potentially of blockchain. I want the immutability, or I want the distributed nature. There are characteristics of blockchain that are valuable for my enterprise. But Ethereum and Bitcoin are just not going to do it because they're public. So a consortium of tech companies, sometime just in the sort of last 10 years, sort of said, look, if this thing is going to be big in the enterprise, and frankly, if we want it to be a solution in the enterprise, we're going to have to come up with some way of having a permissioned blockchain and a private one for an enterprise to use. And so you get this idea of a private permissioned a blockchain. Now, the reason why at the very beginning of my answer I said this is such a fascinating area is, in some ways, the notion of a private permissioned blockchain is sort of like the opposite of the whole point, right? It's like we created something for a very specific reason because we wanted to move away from the very limitations of what we were, of the tradition. And now we're kind of saying, well, we will actually create a version of it, in the world in which we have limitations. Now we kind of have, pulled it off in a way. Hyperledger being the best example, is open source, but it is it allows for enterprises to decide who can join and be part of it for obvious reasons, and it's growing. I mean, you've got remarkable Hyperledger offers from the likes of IBM, right, and the likes of Dell and others. So it's now a legitimate commercial enterprise solution, and they've had to be very creative in keeping the spirit of blockchain, but also limiting some of the features of it.
So going back to that idea of trust, something that comes across quite often whenever I'm researching or reading about blockchain is this idea of the Byzantine generals problem. Like what is who is the Byzantine general, and why are we still doing problems?
Yeah, like hundreds of years later, this is still a problem. Yeah, that's right. Okay, so a little bit more complex, but let's see if I can actually articulate it. So yeah, it is sort of interesting that Byzantine generals problem. We're using the Byzantine, which is from the anywhere from the 400s to the 1300s. We're talking about, Turkey and Greece and that area. And that is actually not so important. What the Byzantine general's problem is, in a sort of a storytelling perspective, there's some armies, right? And this is a long time ago, so there's no cell phones, there's no email, right? No electricity. We're thousands of years ago. About 1,000 years ago, we got generals, and they have armies, and they want to invade a town, right? And there's if they just invade the town themselves, they'll actually lose. But it turns out there's another army from another place that also wants to invade the same town, right? But they don't have a way really to communicate, especially when they're about to invade. But they know that if they join together, if the two separate armies join together, they can invade and actually win and succeed in this town. Now, the problem is there's some distances involved, and they again, the only way they can actually communicate is with messengers. So it's guys on foot, right? Or on horses. And so one general says, everything looks good. We should attack tomorrow at sunrise, 6 a.m. But the other general doesn't know that because he's like 50 miles away. So he gets one of his riders, one of his messengers to jump on a horse and say, will you tell the other general that we're going to invade at, what did I say, 6 a.m.? 6 a.m. Okay, 6 a.m. Tell him and see if he's okay with that. So the rider runs off, goes and does this, and comes back and says, yeah, he's good. They're good. And so you coordinate it. Now, the problem with this is there's a few problems. Number one is, how do you know the rider is telling the truth, right? Because the rider went off, was gone for a few hours, comes back and says what he says. Maybe he was bribed, Another problem is maybe the other general said yes, but then changes his mind for whatever reason, right? Okay, so that's the idea, is that how do you communicate with integrity to different parties that you can't really, that you don't trust and you have difficulty connecting with? How do you ensure that the decisions are good and everyone's on the same page? It's a metaphor for managing distributed systems. Right. And in a whole range of contexts, in systems contexts, this is useful because you're actually trying to solve that problem computationally. Right. And let me say, as you can probably imagine, it's a hard problem to solve in a distributed computing environment. The relationship to blockchain that's what we're trying to do. We have technically hundreds of people that are connected, and we don't know anybody. Like when I go to Bitcoin or Ethereum, whatever it is that I use, I don't know anyone else, right? And yet, when a transaction is placed, we have to have a high degree of confidence that we all agree, and it's a good transaction. It's not a fake one, and it's not fraudulent. And so we need a solution in the blockchain environment to ensuring that decisions are correct and approved, right? And so we do have a solution, and that's what was written about in this paper, this Satoshi Nakamoto paper in 2008. And it's called proof of work. It's proof of work. That's the solution. And that, by the way, is the magic that I spoke about earlier. That's the mathematics that makes it all work.
So yeah, let's get into this mathematics at kind of a high level here, but technical enough for data scientists to understand. Because there's always this mathematical puzzle that people talk about having to get solved when you add a block to a blockchain. Like, is it just like a really hard Sudoku puzzle? Like, what is all this about?
Well, one of the things you want to do when cooperating on a large network and you want people to do the right thing is you want to make it hard for people to do the wrong thing. You want to disincentivize criminals by making it hard to be a criminal, right? And so you need a hard problem to solve. You need to raise the cost of doing bad things. And if you're doing good things, that cost actually is worthwhile, right? Hopefully that makes sense. Now, the best way to explain proof of work, it really is this effort, making it hard to both participate, but also to disincentivize criminal activity. The way to explain it is to talk through a transaction, right? So I'm going to be paying Harpreet I'm going to say 1 Bitcoin, but everybody knows that's a lot of money. Right now, what is it, $55,000 or something? It's fluctuating quite a lot. It's a lot of money, right? But just say for fun, I'm going to pay you 1 Bitcoin. So, you and I both need to be participating in this network, this blockchain network, this Bitcoin blockchain network, alongside, by the way, hundreds of thousands of other people. And so I'm going to now initiate a transaction where I say Jonathan is going to pay Harpreet 1 Bitcoin. And so I basically, create that transaction in my whatever software I'm using. And there's lots and lots of third-party software I can do that, including exchanges and things. So I go ahead and create that transaction. And what happens is it gets broadcasted. And there's a sort of a check, first of all, do I actually have 1 Bitcoin? Fortunately, everybody has a ledger on their computer so they can check, right? But it then goes into a queue. And it doesn't immediately get resolved. What we want is that a process takes place that solves a mathematical problem. Here, I'll tell you about it in a second. That if it's correct, and it's and other participants concede, or by a process of consensus agree that it's the correct transaction, then it gets added to the chain of transactions, which are these blocks making up the blockchain, right? Now, when sort of a pool of transactions are waiting to be processed, there's a new participant on the network called a miner, right? And miners are just another node, another person, another computer that wants to be part of this network. But they're there not for transactions necessarily. They're there to solve this mathematical problem and get paid for doing it, right? They want to get a little bit of Bitcoin, a little incentive, right? Now, what happens is, and I think this will be familiar to data scientists, but I'll just quickly describe it. There's a process in computing called hashing, right? And effectively, hashing is you can take any length string, any length of characters, and put them through a hashing algorithm and get a fixed length output. So it could be the works of Shakespeare, or it could be my name, whatever goes in one side of this algorithm. On the other side comes out, and I say, I want the fixed length of the output to be 64 characters, no matter what. Now, because it's 64 characters, there's a massive amount of combinations, right? So it's going to be statistically, it's close. The probability is that it's close to unique, this thing that comes out. So what happens is you got these transactions that are queued up, and what the Bitcoin software does is it determines that in order to add the block, when the queued up transactions are hashed, right, they should equate to a specific output, a destination output, this hashed number. And the way that happens is a miner, who is the person who's going to do this hashing, they take the input, which is it's collection of all the transactions, and they add a additional character. It's called a nonce, right? It's just a technical term. And in this case, we'll say the nonce is 1. The character is the number 1. And when the input, which is all these transactions plus the 1, are fed through this hashing algorithm, a test on the other side says, is this answer the same or less than, in terms of numerics, the Bitcoin determined output. You still with me? Okay. And so the first time it does it, no. Right? Second time, no. Third time. So now the nonce is going 1, 2, 3, 4, and you continue to do this. Now, as you can imagine, you got to try a lot of times, right? A lot. And depending on the complexity that Bitcoin is determined that output, that target number or target hash to be, if the computing processing isn't sufficient, it's going to take a long time. But what Bitcoin says is you got to figure it out in 10 minutes. That's the time they give you, effectively, 10 minutes or less. And to do that, you need a lot of processing power. Now, the problems have got harder because more people want to participate and more people want to earn Bitcoin for mining. So in the early days, you could probably just do it with your laptop. Back in 2008, you could definitely do it with your laptop. Sorry, 2009. By 2010, you had to use a server. By 2011, you had to have multiple servers. And today, you need the power of a country. It's like some people say, like Bitcoin is using the equivalent of the power of Iceland, to actually figure out these hashing targets. And so, as you can tell, by doing this, there's no, the amount of the cost of actually trying to mess with it is too high for a criminal. But the folks that do it right and get the right output, they get some Bitcoin, and everybody in the network, all the other miners, effectively then validate that hashing solution that the winning miner came up with is the correct one. I know that's fairly long-winded in detail, but your audience likes that, I guess. That is the magic. It's mathematics.
We love that. Yeah, thank you so much for giving us that detail. I know the audience is going to definitely love that one there. And I mean, is that part of the reason why Bitcoin is worth so much? You mentioned that it takes the power of a small country to validate these transactions. Well, somebody has to pay that electric bill, right, at the end of the day. So is this what kind of gives Bitcoin its value? Is that, okay, well, it costs money to mine these transactions. Mm-hmm. So that kind of gets baked into the price, or am I just making stuff up?
No, you're onto it. It very much was the reason for the early rise in value. Mm-hmm. So if we go back, again, 10, 11 years, definitely there was a closer alignment between the value of Bitcoin and the amount of energy expended. But as time has passed, that connection has lightened for sure. It's hard today to know the degree to which that's a contributing factor. We do know that if the number was too low, that, again, you're absolutely right, you wouldn't get as much. You lose the incentive, right? And so people, the system fails. But if it exceeds, if the reward exceeds the input, then you're going to get a lot of participants. What really is driving the price of Bitcoin today is just plain old, what's the next person prepared to pay for it? When you look at the current price, it sort of has gone up a lot over just the last few months. There is some very intense, macroeconomics at work that are sort of over my pay scale. In terms of how all the exchanges are working and how people perceive the marketplace, and then you got the institution investors now in Bitcoin as well. There's a lot of different variables that now it's a lot more complicated. It's moved from being the topic of computer scientists to being the topic of economists, right? Why does it have the value of $55,000 today, let's say, and in a month from now it could jump to 70,000, or it could drop to 30,000. There's a lot of mechanisms at work. One of the things for sure is that there are a lot of people involved. There's a lot of money involved. So there is this sort of the inertia is towards increasing value, because there are more people participating, more people want to get in, so they're buying. So there's quite a high demand. So I hopefully that answered your question, and that it's the reason for the price has shifted over time. Now it's not as well connected with the power, but certainly the scale is contributing, and the amount of transactions are all contributing towards what the market believes the value should be.
As Nassim Taleb once said, it's easier to macro bullshit than it is to micro bullshit. Jonathan, I know we're running up on time. That was just the comment there for the macroeconomics voodoo magic that's causing this price to go up. But I appreciate the time you took to come onto the show. We got to get you back to talk about Ethereum at some point in the near future. So because I plan on doing that, I'm not going to ask you my standard wrap-up question. We'll save that one for next time.
Okay.
But right now, let's just do a couple of quick questions from the random round. And we got the first one coming up here. The random question generator wants to know, what's your favorite piece of clothing that you own?
Oh, I think the right answer should be my Aruba cap, right? Because I'm wearing an Aruba hat right now. People see it on a lot of my videos. I guess that's right. Flip-flops. I love my flip-flops.
Who are some of your heroes?
My father would be probably my number one. And although this is obviously sensitive and I don't know why, big fan of Barack Obama. I think he's an amazing man. I don't care what you think about him as a president. I think as a human being, it's a pretty impressive guy. Yeah,
I got his book sitting right there, Promised Land. I've got to read into that. It's been sitting there for a couple months. Jonathan, I'll include all of your contact information right there in the show notes. Thank you again for taking time out of your schedule to come on to the show today. Appreciate having you here.
Thanks, Harpreet. This was a lot of fun. I'm going to be interested to listen back myself to see if I got the answers right.
Awesome, man. Definitely. Thank you.